All right, guys, let's start off here on number 1. So for this one, and keep in mind here that especially all the red numbers may be different for you. So the way I have it here, when I want to find a sub 1, that really just means plug in 1 for n. And so I'm just going to do 7 plus negative 1 to the power of 1 plus 1. So that's 7 plus negative 1 squared, and that's really just 7 plus 1, so that's going to be 8. So I'll let you guys try the rest of those. Like I said, you're really just kind of plugging in that subscript into the exponent and seeing what you get out. All right, next up here we have the recursively defined sequence, and so that's always where the next term is based on the previous term. Now the good news here is that we already given the first term, and that'll be 1. And so what this right here is saying is that the next term is always found by doing 4 times the previous term minus 5. And so every time I go on to the next term, so when I do a sub 2 here, now that k plus 1 is 2, that's really saying 4 times a sub 1 minus 5. And so you can see what I mean when it says take that previous term, multiply it by 4, and then subtract 5. So in this case, a sub 2 is going to equal 4 times 1 minus 5. And how I got that 1, once again, is just taking that previous term that I had back here. So this one's going to come out to negative 1. So then for a sub 3, same idea. I'm going to do 4 times the previous term minus 5, but now my previous term is negative 1. So negative 4 minus 5 is negative 9. So that'll be my a sub 3. And that pattern is just going to continue. Just every time do 4 times your previous term, whatever it was, minus 5. All right, number 3 here is a little trickier still, and the reason that's a little trickier is that this one says it's recursively defined, and it really is here with these two. So this is going to be the previous term, and then this is going to be the next term. However, we also kind of have an explicit aspect here of this k right here. And so what I would always say is that that k should always match up with whatever number you have down there in the subscript. So I already know a sub 1 is 6, and so when I want to find a sub 2, I'm going to do, well, this one turns into a sub 1, and since that's a sub 1, like I said, that should match up right here with a 1. Now I know a sub 1 is 6, so I'm going to do 1 times 6. So even though it was a subscript as a 1, now as a regular number it's a 6 because that's what the first term was, and that comes out to 6. So now for the third term, I need to do a sub 2, and then when I match up that k value, I'm going to put the 2 up there. And now I'll substitute in 2 times my previous term, which will be 6, and so that one's going to come out to 12. And one more time for a sub 4 now, I'm going to, this a sub turns into 3, and then I'll move that number out front as well, so that's going to be multiplied by 3. And then I substitute in my previous term, which was 12, so 3 times 12 is going to give me 36. Fifth term would be the same idea. I'll let you guys figure that one out. All right, next up here, you can see that they've given us 2 terms. It is once again recursively defined. And so what we'll say here is that if I want to find a sub 3, then that's k plus 2. That would mean that k is actually 1, and that k plus 1 is actually 2. So you can see that I think of this one as like 2 ahead of this one, and then this one's in between. So if this is 1, 1 plus 1 is 2, 1 plus 2 is 3. And so really as I interpret this now, what it's saying is the next term is always the previous 2 terms multiplied together. And so they gave me these previous 2 terms as 4 and negative 2, so that's going to be negative 8. So then when I want to find a sub 4, I'm again going to multiply the previous 2 terms together, but now that's a sub 2 and a sub 3. And so that's going to be negative 8 a sub 3 times a sub 2, which is negative 2, so that's going to come out to 16. And then lastly, when I want a sub 5, that is going to come out to a sub 4 times a sub 3, the previous 2 terms again multiplied together, so it's going to be 16 times negative 8. And let's see, what is that? That'd be negative 128. All right, next up here, they want some partial sums. And so first thing I'm going to do is I'm actually going to figure out what's a sub 1, a sub 2, a sub 3, and so on. Those are not going to be my answers, except for the first one, actually, and I'll explain why. So a sub 1 is going to be 1 plus 1/2 times 1, And so that's going to be 3 over 2, or 1.5. So that's my first one. The second one is 1 plus 1 over 2 times 2. And so that's 1 plus 1, and that is 2. However, the second sum is the sum of the second term plus the first term. So I need to add these two together to get s sub 2, which is actually 3.5. So now when I find a sub 3, 1 plus 1/2 times 3, that's going to be, let's see, 1 plus 1.5, so that'll be 2.5. And then for s sub 3, I got a couple options here. I can add all the first three terms up, or I can actually just take this third term and add it to the previous sum, which would have given me 6. So I think that's the way I would do it, is just take that last term that you found and add it to the previous sum. So now I need to do 1 plus 1/2 times 4, so then that comes out to 3. But again, I need to then add that to this to get my sum of 9. So you need to keep adding along the way. All right, question 6 here. I need to find a sub 1, which would be 4 times 1 minus 7. That's negative 3. And I need to find a sub 2, a sub 3, a sub 4, and a sub 5. And once I get all of those, and I'm not going to do it here, you just add up all the results, since that's what the sigma means, is add them all up and get your final answer down here. So it should be the sum of all of those terms. All right, next up here, find the sum again. So same idea here. I'm going to find a sub 1, a sub 2, and then all the numbers all the way down to a sub 10, get the results, and then add them up. And that'll be your answer. Number 8 here, it's asking for the first 4 terms in the 8th term. So it's not asking for the sum anymore. It's just asking for the terms. So a sub 1 would just be 4 plus 1 over 1. So then that is 5. Next one would be 4 plus 1 over 2, so that would be 4.5. And then the next one would be 4 plus 1 over 3. Now this one would actually be 4.3 repeating, and so I can't type in the repeating here, so I'm going to have to do this one as a fraction. The other ones you could have done as a fraction as well, but this one we just have to. So I'm going to do a common denominator here. So 12 over 3 plus 1 over 3, and that should be 13 over 3. So I'm going to type that in as a fraction. The other ones should be a little bit more straightforward. You can probably use decimals for those. All right, now we're going to switch over to arithmetic sequences, and it mentions that right there. And they first want the nth term, which is really the explicit formula. And so the formula I use for that is a sub n equals dn plus a sub 0, which is really the same as like y equals mx plus b. So I see that the pattern here is plus 3, plus 3, plus 3. So that means that d is positive 3. And then a sub 0 is kind of the hypothetical first term in front, the hypothetical term in front of the first term. And so if I kind of track this pattern backwards, I'm actually subtracting 3. And so this one would be negative 1. So I'm going to say a sub 0 is negative 1. Since a sub 1 is that first term, a sub 0 is in front of it. So my formula then will be 3n minus 1. And then for a sub 5 and a sub 10, I can just plug in 5 or 10 for n and get my answer. All right, number 10 is another arithmetic sequence, but the common difference is a little trickier. So I see that to get from one term to the other, I must be adding 4x, but then I also must be subtracting 2. So I'm going to say the common difference here is 4x minus 2. And then a sub 0, if I kind of think backwards to what would this be, I'd have to subtract 4x, so it'd be negative 20x, and then plus 10. So that's my a sub 0. And so when I want my, my a sub n formula here, I'm going to use my dn plus a sub 0. And so my common difference, since it's actually 4x minus 2, I'm going to put that in parentheses, and then multiply that by n, and then minus 20x plus 10 for my a sub 0 that I had back here. You could also write this with a distributed n in there, so 4xn minus 2n, that would also work either way. So now for a sub 5, what I'm going to do is just take this formula and plug in 5 for n. I'm not going to plug it in for x because it really represents n here, so I'll plug in my 5. and I'll go ahead and distribute that. So I get 20x minus 10 minus 20x plus 10, which actually has everything canceling out and ending me up with 0. So that was just kind of a coincidence there that ended up being 0. So now when you do a sub 10, you should be left over with some stuff, so I'll let you guys try that. All right, next up here, we are going to come up with an arithmetic sequence here. And so I'm going to first find the common difference. Since these two are in order, I can subtract them backwards to find that. So it looks like my common difference here is, let's see, negative 1.9. Now I need my a sub 0. So I know that a sub 0 is going to be bigger than a sub 1 in this case because it's a decreasing sequence. So a sub 0 is just going to be my a sub 1 plus that common difference. And so that would be 11.6. And that actually makes sense here if you kind of look at how the sequence is working, that's 11.6. All right, and so now I can say a sub n equals my common difference times n plus my a sub 0. So if I need a sub 12, I would just plug in 12 to that formula. All right, next up here, number 12. Okay, so first question here is what's the number of terms? So obviously that's 5 if you just count them up. The common difference, it looks like for me, is plus 9. And so now we need to express it in summation notation. So first of all, I notice here that they made me put 0 at the bottom. So that means this first term is actually a sub 0. This is a sub 1. That's a sub 2. That's a sub 3. And that's a sub 4, which means that I know I'm going to stop at 4. And then my formula is going to be 9n because that's the common difference is 9. And then I notice here that since this is a sub 0, I'm just going to add that out back. So that becomes 9n plus 6 since our formula for this is going to be dn plus a sub 0.